Hi, this is Byron from Period 1, and today I would like to go over, in this video, the physics of soccer free kicks. So what exactly is a free kick? A free kick is when a player who is on one team kicks the soccer ball toward the opponent's net while it is stationary. These are usually awarded after an opposing player commits a foul on said player. And a foul is basically a play that goes against the rules of the game of soccer. As you can clearly see in these free kicks, a number of different techniques can be evolved when taking these kicks. For example, here's a free kick I decided to test out on my own house using the outside of my foot. As you can see, the ball curves clearly to the outside. And vice versa, here's a shot showing me taking a free kick from the inside of my foot, curving it to the other side of the post, the left side. Lastly, here's me taking a free kick just straight to the center of the goal. So you might be wondering, how do these curves even work? What are the physics behind them? What are the forces that act on the ball? So here's a picture of the Magnus effect. The Magnus effect illustrates the forces that act on the ball while it has a certain spin. In this picture, the velocity of the air around the top half of the ball is different, actually less, than the air velocity around the bottom half of the ball. This is because the tangential velocity of the ball in the top half acts in the opposite direction to the airflow, and the tangential velocity of the ball in the bottom half acts in the same direction as the airflow. Using what we have learned from the pressure chapters from the physics book, we can deduce that the airspeed having been reduced on the top half means that there's a net downward force in the ball because the pressure is greater on the top of the ball. This is because Bernoulli's principle states that when we have decreased air velocity, air pressure increases, and vice versa. Which is why we know that the air pressure increases. So here's a simple diagram of left and right kicks. That's how it curves. So that's how it worked in the video. Now we can compare collisions between two different subsets, one being elastic and one being inelastic. Elastic collisions are collisions where a certain amount of compression happens to the ball and a little bit of energy is imparted to the ball. Not as much as if it was completely inelastic. So basically it gets compressed and it moves forward. Inelastic collisions. So are different from inelastic because inelastic collisions have no compression. Completely inelastic collisions have 100% efficiency rates. So efficiency is a major way to differentiate between the two of them and the way they compress. So we can surmise from our understandings of inelastic and elastic collisions from the chapter where we learned about the constant called the coefficient of restitution, defined as this equation. The coefficient of restitution dictates how elastic something is. For example, coefficient, if it's 1, that means it's completely elastic, and if it's 0, it's completely inelastic. Okay, so that marks the end of our discussion of collisions and free kicks in soccer, and I hope you enjoyed this video.